Alright, hi everyone. So yeah, today we are going to resume our lesson on Pure Maths 3 and we are moving into a new chapter which is vectors. So it's topic 7 based on your syllabus, but if you are referring to your textbook, then it will be chapter 9. Alright, okay. So for today's lesson, it's going to be like a basic introduction for the chapter, which mean some of the terms actually you have learned it before during IGCSE. So it's basically more on like a recap or a revision for you. So for next week lesson is going to be like harder than the content that we are going to learn is going to be much more difficult. Okay, so let's look at the learning outcome of the lesson. So today we are going to learn how do we use the standard notation of vector. So it can be like column vector, so it can be like the vector in component form or even like in a capital letter or a small letter. Okay, so the standard notation. Then the second one is we need to know how to carry out the addition and subtraction for vector and also multiplication by a scalar. And we understand what is this operation meant in a geometrical approach. Okay, then after that, the last one, we need to know how to calculate the magnitude and also how to use the unit vector and to identify the difference between a displacement vector and a position vector. Okay, so it's going to be like much more like a terminology kind of lesson. So which means that uh the content itself is much of like theoretical rather than like a practical approach. Okay, so in this lesson, the vectors that we are going to look at will be including both 2 dimensions and also 3 dimension. Okay, so these are like the summary of the lesson for today. Okay, so let's start with the introduction. Alright, so the first concept that we'll be looking at is called as displacement vector or translation vector. Okay, so if you can recall, a vector is actually a quantity which has both magnitude. Okay, so magnitude meaning like the size and also direction. Okay, so for example, a very simple illustration will be like if you, let's say you have distance versus the other one is what we call as displacement. Yeah, so we know that distance we talk about the magnitude only, so it is a scalar quantity. Then for displacement, other than we talk about the magnitude, it also involves direction. So displacement is like one of the vector quantity. Okay, so it's the same thing like when you try to compare like speed and velocity. Yeah, it's like kind of similar also if you learn physics. Alright, okay. So displacement or a translation vector describe a movement from one point to another. So basically, it's like a translation itself. Okay. So there are few ways that we can try to represent a vector. So much more clearer one will be by using a diagram. So you will be drawing a line segment and after that label with an arrow. So by using the line segment, then we try to indicate the magnitude, meaning like the length of the line. Then the arrow indicate the direction. Okay. So a vector between 2 points L and M here can always be described as, so sometimes we try to call it as, if let's say this is C, so this is called as vector C. So how do we indicate that it's a vector? So we will try to make a wave under it. Okay, or sometimes when you look at some textbook, right, they didn't write in this form, but they try to write in C, but it's in bold. Okay, but I mean, when we are using handwriting, it's very hard for us to like differentiate whether you bold it or not, right? So that's why very I mean a much more clearer way of express it is whether it's a vector or not is by putting the line under it. Okay, so the other way is L. You can see that the arrow points from M to L, so that's why this vector is also called as ML. Okay, and we'll be putting an arrow at the top there, and the arrow must be from left to right. Okay, so you do not have something like this. Yeah, so make sure that it's always left to right and it must follow the direction of the arrow. Okay, so the order of the letter is important as reversing the letter actually means the opposite direction. Okay, so this is some basic knowledge that you should know already. Okay, So that's why a negative vector has the same magnitude but the opposite direction. Alright, so for example, if let's say when we try to compare the diagram that we have above, right? So we know that, for example, ML is going to be, so when you try to look at ML and QP, it's actually the same magnitude, but then for the vector ML, the arrow is moving down, then this one is moving up. So that's why ML is equal to negative QP. Okay, so the other, negative PQ. Yeah, my callus. Yeah, so ML will be equal to negative of PQ. Alright, so it's the same thing as well if we try to put PQ in front, so which means that PQ is actually equal to negative ML. Okay, so you can see the difference between it. Alright, so after that, so that's why we know that AC equal to negative CA is always true. Like for example, when you try to look at this, right? So ML is actually the same thing when we say negative LM. Okay, because negative, which means we try to change the, so okay, for example, ML is from M to L, right? So when we say LM and it's negative, which means that we try to reverse the direction, so it will become ML. So that's the idea. So vectors are equal if they have the same magnitude and also the same direction. Okay, regardless of where they are. So for example, if let's say I have a line here and I have a line here, so as long as these two, they have the same magnitude and same direction, the vector is the same no matter where they are. So for example, if based on this diagram here, so we know that PQ, the vector for PQ is actually the same with the vector of AC. Yeah, okay, so we just try to assume that everything here is like the same magnitude and is parallel. Okay, so the direction of PQ and the magnitude of PQ is exactly the same with AC. Alright, so PQ is equal to AC. So a quantity that we use to scale a vector is called as a scalar. So this is the part that we talk about the scalar multiplication. So for example, when we try to look at some comparison, right? So we know that for two, so AB, if let's say AB and CB is actually the same length, so meaning that AC will actually equal to 2AB, right? Like what you can see here. So like AC will be equal to 2AB. Or it's the same thing when we try to talk about AC is actually the same when we compare to 2BC. Okay? Or even when we try to compare PQ and AC, which means that PQ is also equal to 2AB as well. Okay? So this is like some of the basic knowledge that I hope that you can recall. Alright, so let's try to continue with the next one. So we are going to look at what we call as a parallel vector. So this is the same thing when we try to compare to the scalar multiplication that we have. So two vectors are parallel if one is a scalar multiple of the other. Okay, so for example, when we try to compare the diagram above, right, so we know that PQ and AC is actually parallel. So which means that you can write it in the form of PQ is equal to AC, and then when we try to compare even like the A part, so which means that we can always write B will be equal to 2A. And the 2 here is basically what we call as the scalar multiple. So if let's say we can try to write it in this form, which means that they are parallel. Okay, so the concept tells us that if A, the vector A equal to lambda B and alpha and the lambda is a scalar, then A and B are parallel. Okay, so if let's say alpha is greater than 0, it actually means that they are parallel and they are in the same direction. Okay, So which mean, for example, if let's say we try to do a easy illustration here, so which mean if let's say I have a graph like this, then I have the other one maybe longer, but the direction is actually the same, which mean that we know that they are parallel. Okay, then the other one is that parallel. If let's say the lambda is a negative number, it actually means that it's parallel but it's in opposite direction. Okay, because when we talk about whether a line is parallel or not, we actually do not look at the direction. We actually only talk about like whether the line is parallel in a geometrical way. So if let's say this line and this line, yeah, you can see that they are parallel also, but it's just that the direction is opposite. So that's why the lambda will be a negative one. Okay, so now we'll be looking at the component of a displacement vector in two dimension. Okay, so this is the thing that you should have known already as well. So any displacement can be represented by the displacement in x direction followed by the displacement in y direction. It's exactly the same like how you write a translation. So it is normally represented by a column vector. Okay, so a column vector will be look like this, and this is like the x direction, then you have the y direction. All right, so for example, coordinate -2 1 will be translate to b1 2 by the vector of, yeah, so you will be moving 3 to the right, so 3. So like -2 need to plus 3, you only go to 1. So 1 need to move 1, then you can reach 2. So by the vector 3 1. Okay, so same thing when P move to Q, so which means that the vector will be -3, then after that, -2. So it's the exactly same thing like how you do translation. So positive meaning you're going to right in the x direction or you're going up in the y direction. So if negative meaning you're going to left or you're going down. All right. Okay, so something that may look new for you will be this part, which we also will be looking at the component of a displacement in three dimension. So three dimension meaning you will have like 3 points. So we'll be using three coordinate, which is x, y, and also z. Okay, so the three axes here, right, they are perpendicular to each other and they can be rotated. So rotated meaning that it will be depends on how you want to draw it. It is not that, so normally when we try to talk about the 2D one, it will be normally this is our x and this is our y, right? So for 3D one, it can be rotated, so it depends on how you want to draw it. So the same thing, if let's say for a 2D one, you will need to have two components, which is the movement for the x direction and y direction. So which means in 3D one, we will need to have three components as well. So which means that you will have x, y, and z. What is the movement for all these three directions? Okay, so I'm just showing you like one of the idea for the rotation here. So for example, a normal one, then we'll be drawing like x here, y, and this is the z. Okay, so the 90-degree, which means that for x and y, right, we know that this is 90-degree. So when you try to look at it like a 3D one, meaning here to here is also a 90-degree. So it's same thing like x and y is also 90-degree and y and z is also 90-degree. So that's like the idea of it. So, or you can try to rotate it. For example, you want to let your x to be here, then after that y here and z here also can. Okay. So the difference is that, for example, if we try to talk about easy, if let's say we have all positive, I want to move along the positive x, positive y, and positive z. How will it be look like? So if I'm moving on the x-axis, right? If a positive one, then it will be like this. A positive x, then positive y, follow this axis, right, then it will go up. Then after that, if positive z, then meaning that it will go there. Okay, so that's like the idea of how it moves. So same thing, if let's say x, y, z, if I'm moving on x, then it will be like this. Then I want to go to y, then it will be like this. Then if I move along the z, then it will be like this. Okay, so yeah, the idea is like we know that this is 90, this is 90, and xz, this is 90 as well. Okay, so the same thing, if you want to draw it like this, so perhaps x is like this, y and z. So you can look at it like this is like on a same plane, then after that y is like going behind. So we know that like this is our 90 degree. So here to here is also 90 degree. So they are always like 90 degree to each other. Yeah, so that's the idea. So if let's say in this case, right, how it moves. So the same thing, if positive, then positive x, then positive y. Okay, then after that positive z, it will be going up. Yeah, so that's like the idea of how it looks like in a 3D Cartesian plan. All right, so it's the same thing if let's say I'm moving a coordinate t 137. If I want to translate to q, which means that the vector will be look like, so 1 to 5, it will be a movement of positive 4, right? So 3 to 3, it will be 0. Then after that for z is 7 to 2, so which means negative 5. Okay, so that's the idea for like a component of displacement in 3D. Okay, so that's the basic introduction. Let's try to do like these two simple questions before we move on. Okay, so these are pretty simple example that you can try your own first, then after that you can check answer here. Okay, so right in terms of ABC, the vectors x, z, y, z, yc, za, and bx. Okay, so let's start with the first one, the zy. So we know that zy is from here to here. Okay, so we can see that this line and this line should be parallel. So that's why zy should be the same with ax. So that's why your answer should be A. Okay, then after that, the next one is yc. So for yc is going to be here to here. Okay, so it's exactly the same with with xz. So that's why we have B. Okay, then after that ZA. So ZA is the opposite. Yeah, so we can see that from A to Z is C. So ZA is going to be negative AZ. Alright, so that's why your answer should be negative C. Alright, then BX. Okay, so you can see that bx here is going to be exactly the same like xa also, but it's in the opposite way. So negative is going to be negative ax. All right, so that's why your answer should be negative A. All right, so let's move on to number 2. Okay, find the value of t if let's say the given vectors are equal. So we know that if they are equal, which means that every element must be the same. So which means that 5 plus t is equal to 3, right? So that's why I have t will be equal to negative 2. Okay, so we need to check again for the last one and see whether we have the same t or not. So 3 minus 3t equal to 9. So 3t will be equal to negative 6, so which give you t equal to negative 2. So we know that the answer is the same, where t is negative 2. Okay, so for B, the value of k if the two vectors are parallel. Okay, so if let's say they are parallel, which means that we can always write 2, negative 1, 6 equal to lambda. Okay, so 8, negative 4k. So if you are not familiar with the to use a lambda here, you can use anything like a mu or even like a can be accepted as well. So the idea is that you know that there is a scalar factor that. So 2 will be equal to 8 lambda, right? So yeah, for the x direction, so we can know that lambda will be equal to 1 over 4. Right? So 1 over 4. Okay. Then after that, when you try to check again, right, you can see that negative 1 is equal to 1 over 4 times negative 4. So you know that is correct. So that's why we can continue. 6 will be equal to lambda k. So that's why 6 equal to lambda is 1 over 4k. Alright, so k is equal to 24. As simple as that. All right. Okay. So let's move on to our let's continue our notes. All right. So the next section will be looking at the addition and the subtraction of vector. Okay. So let's try to do this. Yeah. So given that the vector AB, so you can see AB here is going to 1, 2, 3, 4, 4 positive in the x direction, then after that 1, positive 1 for the y direction. Then for C is going to be 2 positive x, then after that 1, 2, 3, 3 positive y. Okay, so what is the overall displacement that you displace, you relocate the coordinate at A to coordinate C. So which means that the displacement is from here to here. All right. So what you can realize here is that when we try to write AC, right? What's your answer? So it's going to be like 1, 2, 3, 4, 5, 6. So 6. Okay, then after that it's going to be here, then 1, 2, 3, 4. So the overall displacement is going to be 6, 4. Okay, so when we try to check this out, right? Okay, later we try to do one more here. So for the PQ is going to be 1, 2, 3, and then 1, 2. So 3 positive, then negative 2 because going down. Then for QR 1, 2, 3, 4, and 1. So 4, 1. And RS is 1, 2, 3, then 1, 2, 3. So sorry, 3 to the left, then after that 3 going up. So what is the total displacement? So meaning it's from P to S, right? So it's from here to here. Okay, so which means that the total displacement PS is actually, when we try to count it, then it will be 1, 2, 3, 4, then 1, 2. So the overall displacement is 4, 2. So the answer for AC and the PS here is actually called as resultant velocity. So how can we get this answer? Because just now we try to look at it like in diagram form. So which means I try to draw how is AB, then how is BC. Then I try to connect A and C together, and I calculate for the how many units we need to move in terms of x direction and y direction, so we can get the displacement. But actually the two components can also be found by trying to add them together. So which means that if let's say AC, okay, is going, AC here is going to be equal to AB plus BC. So from our answer just now, we know that AB is actually 4, 1, okay, and BC is 2, 3. So from here, then I try to add them up respectively, meaning 4 plus 2, then I'll be able to get 6. Then 1 plus 3, I'm going to get 4. So that's why you see my last answer is 6, 4. It's the exactly same answer when I try to calculate it from the diagram that I have. So the same thing, we try to try PS. So for PS, just now, what do we do? So what happened here? So it's from P, move to Q first. Then after that, Q move to R, and then R move to S, right? So when we try to add them up together, then it's going to be 3, negative 2, plus 4, 1, plus negative 3, 3. Okay, so we try to add them up together and see. So 7 minus 3, then I get 4. So negative 2 plus 4, then I get 2. So you see, the answer is exactly the same when we try to straight away calculate it from the diagram. Okay, so what we call this operation is actually called as vector addition. So this is like how we try to add two vectors together and to find the resultant vector. I'm sorry, this should be vector. Resultant vector, not velocity. Okay, so generally the vector addition can be interpreted as moving from a starting point to an ending point by any road. So which means, like for example, the starting point is A, so ending is C. Yeah, so no matter how you move, so which means if let's say it's not A, B, then C, you can be like A, then you go to like X, Y, Z, then you go back to C. Eventually it will give you the same resultant vector. Okay, so that's the idea. So when you try to look at this, right, normally your resultant velocity will have the same starting point as your first vector, then it's going to be the same ending point for your last vector. Okay, so same thing, AB plus BC. So you start from A, then go to B, right? Then from B go to C, from C go to D, from D go to E. So you start at A, then go to E. So that's why your resultant vector is going to be AE. Okay, so that's the idea. So the second one, we talk about subtraction. Okay, so what is subtraction? We try to look at it in this way. So we know that a minus b is the same when we try to write a plus negative b, right? So the vector subtraction is actually defined as the addition of the negative of a vector. Okay, what does that mean actually? So we try to look at this example. So for the picture here, we need to find the vector AB and also the vector CB. Okay, so for AB is going to be 1, 2, 3, 1, 2, 3. So it's positive 3, then positive 3 for X and Y. Then after that, CB from C to B. So it's going to be 1, 2, 3, 4. So negative 4, then going up for 2 units, so 2. Okay, so when we have this, right, if let's say we try to find AC, by using the principle that we learned in addition, we know that if let's say we want to find AC, we'll be using AB plus BC, right? So in this case, because we do not have the vector for BC, but we have the vector for CB. So how do we relate how do we relate BC to CB? Is that AB will plus negative CB by using the idea that we learned in negative, right? Because BC is eventually the negative of CB. So what is this? Then this will become a negative. So AB minus CB. So we can try out the answer. So if let's say AB is 3, 3, then after that minus CB here is negative 4 and 2. So we try to do the normal subtraction. So 3 minus 4, then I get 7, then 3 minus, then I get 1. So you can try to check it out whether it's correct or not. So 1, 2, 3, 4, 5, 6, 7. So 7 in the positive X direction, then 1 positive Y direction. So which means it's correct. Okay, so it's the same thing if let's say we try to talk about in a polygon. So when we have this picture, then we have PQ is 4, 2, then QR is 2, then 1, 2, 3, 4, 5, negative 5. Okay, then for SR, I do not, so SR is from S to R, right? So 1, 2, 3, 4, positive 4, then after that the displacement for Y direction is 0. Okay, so same thing if let's say I want to find PS, what I'll be doing, so I'll need to do PQ plus QR and then plus RS, right? But because of in this picture I do not have RS but I have SR, so which means that it will become PQ plus QR then minus RS. Okay, because plus negative RS. So, oops, I'm sorry, should be plus SR. Yeah, perhaps I'll try to write the full one. So, plus negative SR. So, negative SR is actually equal to RS. Okay, so now we can try to continue that. So, which means that it will actually equal to PQ plus QR then minus SR. So we try to substitute the vector that we have here. So 4, 2 plus QR is 2, negative 5, and then SR here is minus 4, 0. Okay, so 4 plus 2 minus 4, then I will get 2. Then 2 minus 5, then I get negative 3. Alright, so you can try to check is that correct. So for PS, it's like 2, right? Then after that, 1, 2, 3. Okay, so which means the idea is correct. Okay, now let's try to look at this example. Then we try to practice a little bit on the scalar multiplication and also addition and subtraction. Okay, so example 3, PQRS is a quadrilateral, then M is the midpoint of RS. Okay, so which means that we know the distance between here and here is going to be the same, right? Okay, then PQ is A, so PQ is A. Yeah, so you can see that some of the book, if let's say they cannot like do the wavy thing, then they will try to do make it like in a bold like font. Okay, so you know that it's actually a vector. So B, then PM. So yeah, every time when you try to label a vector, then it will be very helpful that you try to put in like a direction. Okay, so PM is 1 over 4, and then 2a plus 5b. Alright, so questions A, they want us to find an expression in terms of A and B for Sm, then give your answer in the simplest form. So Sm is here. Okay, so from this picture, I guess it's quite obvious that since we have these two vector, which means that we can treat Sm as the resultant vector, then we can try to solve our equation. So A, we want to find Sm. Okay, so Sm will be equal to, so according to the addition law, so I know that Sm will be equal to the starting point is S, then I pass through P, right? So Sp plus Pm. Okay, so in this picture, because I do not have Sp, so I need to use negative. So Sp is going to be negative Ps. Alright, and then plus Pm. So now I can use the information that I have. So negative Ps is going to be negative, so Ps is B. So plus 1 over 4, then 2a plus 5b. Okay, so let's try to expand it and get our answer. So 1 over 2a. So negative b plus 5 over 4b, then I'll be able to get plus 1 over 4b. Okay, so that will be our answer. Alright, so move on to B. Find an expression for QR. Okay, so for QR is here. Alright, from here to here. So you have actually two choices over here. So either the first one, because when you try to look at it, right, you can actually go through the route of if you want QR, so it can be like QP, PM, then MR. Or you have the other alternative, which is QP, then PS, then SR. You can try both, but both will just give you the same answer. Okay, so perhaps we try to go through the outside one because like doing the addition and subtraction for AB will be easier. So meaning that QR, perhaps I will need to write here. Okay, so B. So QR will be equal to QP, right? And after that plus PS, and then I need to plus SR. So because I do not have SR, but I know that these two is the same, so which means SR will actually equal to 2SM. Okay, so or you can write QR first here, then after that, the next step, you could try to change it to 2SM. Alright, so for QP, I'll be able to get it from the picture here. So QP is the opposite for PQ. So that's why it's going to be negative A. Okay, so maybe we do it step by step for this time. So negative PQ, right? So plus, so how about PS? Yeah, PS is just going to be PS. Then after that, plus 2SM. So perhaps for the first one, we can try to write QR first. Alright, then move on. So negative PQ, it will be negative A, and then plus PS is B, and then plus 2SM is going to be 2. Then your answer in A, so 1 over 2A plus 1 over 4B. Alright, so from there, then negative A plus A, then I do not have any A, then B plus 1 over 2B, then I get 3 over 2B. Okay, so that will be my answer. So you can always try to check this with another alternative. So I'll try to write here. So the other way that you can try to do is QR will be equal to QP and then plus PM, then plus MR is going to give you the exact same answer as well. Okay, so it depends on which one you prefer. Alright, so C, describe the quadrilateral PQRS and justify your answer. So it will be easier that we try to write down everything here. So yeah, because we want to check the characteristic for the quadrilateral, right? So we know that QR is 3 over 2B. Okay, then for SR, we can try to expand this a little bit. So I will have A, then plus 1 over 2B. So we can see that from here and here it's not going to be parallel because I cannot write it as if like in a scalar multiple thing. So that's why, but when I try to check of this, right, I can actually realize that PS is B and QR is 3 over 2B. So which means that if let's say PS is B, right, and then QR is 3 over 2B, which means I can always write QR will be equal to 3 over 2 PS. So this is the concept for the parallel vector that we mentioned just now. So this is like the form of A equal to lambda. So 3 over 2 is the lambda and then B. So A equal to lambda B. So that's why because QR equal to 3 over 2 PS, so we know that QR is actually parallel to PS. Okay, so because of this, so we know that these two, they are parallel to each other. So what is this quadrilateral called? Yeah, so this is a trapezium. All right, so trapezium, which means you have two, so you have different kind of trapezium, right? For example, like this, also called as trapezium, so like two parallel. Then after that, like this is like a parallelogram. So yeah, but if let's say here and here is not the same side, which means that maybe I try to draw it better. So like this, so this is like shorter and this is like longer. So this is called as trapezium as well, or sometimes you have like this thing is also trapezium. So as long as you have two opposite length, which is opposite side, which is parallel to each other, then it's called a trapezium. So that's why PQ. So the idea is you need to identify that QR is equal to 3 over 2 PS. So the line for QR is actually parallel to PS. So that's why PQRS is a trapezium. Okay, so just like that. All right, so we try to continue our notes for the next part. All right, so in this part, we'll be talking about the magnitude of a vector and also the unit vector. So the magnitude of a vector is actually the length of the line segment which representing the vector. Okay, so we know that like in a vector, we talk about the magnitude and also the direction, right? So this is the part that we try to find the magnitude itself. So how do we find it? It's by using the components of the displacement, meaning like how many units you move in the x and how many units you move in the y, and also by using Pythagoras theorem. Okay, so because the formula here, right, will not be given in your examination. So that's why it's very important for you to understand what is magnitude. So every time when you think of this word, right, you will be able to solve it. So the magnitude of vector is represented by, if let's say we have a vector P, right? So the magnitude of P will be written as modulus P. Okay, so this is also known as the modulus of the vector. So let me try to explain the idea in this way. So in two dimension, right, we know that if let's say we talk about AB, so which means if let's say this is our vector, so it will be A and B, right? Okay, so every time when we talk about the column vector here, so it will be x unit move in the x direction. So which means from here to here is like the x. So from then after that, then we'll be moving in the y direction, right? So this will be the y. So if let's say I want to find the magnitude here, then you can see that this is actually a right angle triangle. So how are we going to solve that? Then we'll be using our Pythagoras theorem. So to find the hypotenuse, which is our vector here, then we'll be using x squared plus y squared, then putting them in a square root. So it's the same thing like c squared equals to a squared plus b squared. So we want to solve for c, so it becomes square root, right? So that's why in a simple way, we say that for magnitude for AB, it will be equal to square root x squared plus y squared. Okay, so it's the same thing if let's say we have a 3 dimension, so which means we have 3 component x, y, z. So the magnitude for a 3 dimension for the vector of AB, it will be equal to square root x squared plus y squared plus z squared. Okay, as simple as that. Okay, so moving on from magnitude, right, we have what we call as unit vector. Okay, so a unit vector is any vector of a magnitude of length 1. Okay, so if let's say I have a magnitude of A, right, then the unit vector of A will be written as A cap. Okay, so let me try to explain this concept in this way. So if let's say I have a vector, maybe A to B, okay, so the vector is A. So they have a column vector of, let's say, 3, 4. All right. So if let's say I want to find the magnitude of this vector A, right, then I'll be able to carry out the Pythagoras theorem, then 3 square, 4 square, then square root, then I'll be getting 5, right? Okay, so the magnitude of vector A is actually 5. Okay, so this vector is not a unit vector, right? Because it has a magnitude of length 5. It is not magnitude of length 1. So how am I going to convert this magnitude to be a unit vector that has a length or has a magnitude of length 1 only? So which means I will need to divide this vector with the magnitude itself. So instead of having a magnitude of 5, I want it to have a magnitude of 1. So which means what am I going to do is the unit vector for A is eventually equal to 1 over 5 multiply my vector. So I'll be getting like 3 over 5 and 4 over 5. So this become my unit vector. Okay, so let's try it out. Okay, you see, if let's say I say that this is a unit vector, which means that it must have a magnitude of length 1, right? So let's try to check it. So when I try to check the magnitude of this unit vector, so which means that I'll be doing my x square and then plus y square, right? So when you try to carry this out, then you will be able to see that I'll get 9 over 25, then plus 16 over 25. Then I'll be getting square root 1, right? Which means it will give me 1. So this vector eventually has a magnitude of length 1. Okay, so which means that this is our unit vector. Okay, so to put it in a organized way, to find a unit displacement vector, we need to do two things. So the first thing is to find the magnitude. So we need to know that what is the exact magnitude for the original vector first. Then after that, we will divide the component, like what we try to do here, divide the component by the magnitude. So that instead of having 5, after I divide 5, then the magnitude become 1. So that's the idea. Okay, so you can just remember, find the magnitude, then divide the component by the magnitude that you have found just now. All right, so by looking at these two ideas, the magnitude and unit vector, now we will try out like the 3 examples here. Okay, number 4. So this wouldn't be like a very difficult one. Yeah, so just to use the idea that we have learned just now. So find the magnitude of each of the vector A, B, and also A minus B. Okay, so let's start with to find A. So the magnitude of A will be equal to the square root of x squared, so meaning 4 square plus 3 square. Okay, so from here, then I'll be able to get my first answer, which is 5. All right, then to find B, so same thing. So the difference is just that it's negative 3, but remember after you square it, it will eventually become positive 9 as well. So 4 square. Okay, so same answer, 5. All right, then A minus B, so which means that we might need to find out A minus B first. So for A minus B, it will be equal to 4, 3 minus the B is negative 3 is 4. So from here, then I will have 7 and then minus 1. All right, then by using this answer, then I can find the magnitude of A minus B. So which means it's going to be 7 square plus negative 1 square. Okay, so square root 50. So if let's say we try to change it into a third, so which means 25, so 5, 2. All right, okay, so for part B, so P, yeah, this is a three-dimensional space vector, but the idea is actually the same. So find the magnitude of P plus Q, so which means P plus Q will be equal to 5, 0, 8, and then plus negative 1, 8, negative 3. So from here, then I will get my answer as 4, 8, and 5. Okay, so the magnitude of P plus Q will be equal to square root 4 square, 8 square, and also 5 square. And your last answer will be 105. Alright, and I don't think you'll be able to simplify that anymore. Okay, so just leave your answer in that. Okay, so let's move on to number 5. So find the unit vector in the direction of square root 5, 2. Yeah, so this is exactly the same thing like what I tried to do just now, like the 3, 4, 1. So remember, to find unit vector, the first step is to find the magnitude, right? So the magnitude of the unit vector for the vector 5, 2, okay, is going to be equal to, so square root 5 square and then plus 2 square. Okay, so 5 plus 4 square root 9, which gives me 3. So after I get the answer, so for the unit vector, yeah, so since there's no like any notation that given, so maybe you need to write unit vector of 5, 2 will be equal to, yeah, so magnitude divide, right? So you can 1 over 3, 1 over the magnitude and multiply by the component in your factor. Okay, so your last answer will be square root 5 over 3 and then 2 over 3. So if let's say you are confused with your answer, then you can always try to check and see whether this unit vector has a magnitude of 1 or not. If yes, then which means your answer is correct. So you can try to look at it like after you square it, then you have 5 over 9, right? After that, after you square, then you have 4 over 9. So when you plus it, then you get 1 last. So square root of 1, you get 1. So which means this answer is a correct one. Okay, so move on to 6. So point ABC, so this is the same thing, but it's just that in 3 dimension, and they want us to find AC, so which means that you will need to find AC by yourself first. So for AC is going to be AB plus BC, right? So by using the information that's given, so I have AB is 3, 4, 1, and BC is 11, negative 2, and negative 1. So I know that AC is 14, 2, and then 0. Okay, so after I have this, then I move on to find the magnitude of AC. Okay, so 3 dimension, and since the last one, the last component is 0, which means you only have 2 lah, so 14 square plus 2 square, then you'll be able to get 200. So if let's say 100, then it will be 10, the answer 2. Alright, so this is the magnitude. So that's why if we want to find the unit vector, then it will be equal to 1 over 10 sub 2, then multiply with AC 14, 2, and 0. Okay, so depends on you. So if let's say you want to expand it, then which means your answer will be 14 over 10 sub 2, 2 over 10 sub 2. So since it's 0, so it's going to be 0 as well. So let's try to simplify a bit. So 14 and 10, so which means you can 7, 5 sub 2. Then after that, 1 over 5 sub 2, then 0. Okay, so same thing, you can always try to square your answer and see whether it's correct or not. So let's see, if let's say 49, right, then after you square, you have 25, then it's 50. So plus 1, then 5 square, 25 times 2, so 50. So 50 over 50, then you get 1. So we should know that this is a unit vector because the magnitude is going to be 1. Alright, so yeah, I hope that you shouldn't have any problem up to here. So it's just like formula and it's quite straightforward. Yeah, so which means this lesson is actually not that difficult yet. So that's why we try to learn all this like idea thing in this lesson. Then after that, next week we'll be looking at much more complex questions and more complex idea. Alright, so now we move on to the last part of the lesson, which we try to discuss about the position vector. So for the last part of the lesson, we are going to talk about position vector. So previously we have learned the word displacement vector, right? So displacement vector basically describe a change in position. So meaning like for example the vector AB, which means like how do we change A to the position of B. So how many units that we need to move in the direction of X, Y, or Z if you have a 3D space. So it's basically generally like a free vector because there is no particular starting point. Okay, so I'm going to explain this like in a simple illustration. So which means that when we try to talk about a vector AB, right? So if let's say AB or like A is a vector of maybe 2x plus 3y. So what do I have here is I have a vector that move to my right hand side for 2, then after that go up for 3. So if this is my vector, so I do not have any particular starting point, so which means that if let's say I want to draw it here also can, as long as I have the same magnitude and I have the same direction that I want. You get what I mean here? So it's like a free vector. But now when we talk about the word position vector, right, it describes the displacement from origin only and to a point. So which means that there is a specific starting point for the vector itself and it must be the origin. Okay, so for example, in this case, when we try to talk about a 3D space here, so a point with a coordinate P here can be represented by the position vector from the origin to P. So what is the vector here? So if let's say the coordinate for P is xy, which means that the column vector will be xy. Or sometimes when we try to write it in component form, then it will be xi plus yj. Okay, so what is I and J? I and J is the general form for a unit vector in the x direction. So if you can recall, right, unit vector, we talk about vector of a magnitude of length 1. So which means that, for example, if this is y, so which means this is going to be 1, then after that 2, 3, 4, 5. So this is like yi. So y unit of I. So that's why it's like xi then plus yj. So that's the idea. So same thing if let's say this is like in the 3D spaces, right? So if for the coordinate for Q, it will have a position vector of OQ. Okay? And the column vector will be same x, y, z. So because we have 3 components, so it's going to be xi plus yj and then plus zk. Okay, so this is like the position vector. So you must remember that I, J, and K, right? So if let's say we try to talk about 2D, then it will be I and J lah. So it must be perpendicular. So sorry, I should put this first. So I, J, and K are unit vector. So it's important for you to remember that it's always having a magnitude of length 1, which is perpendicular to each other. Okay, so yeah, that's the idea. So I hope that you can differentiate the difference between the displacement vector and position vector. So basically the difference is just that position vector, you have a particular starting point and normally we refer to the origin. So for displacement vector, normally it can be anywhere. So if let's say like here, then I add up here to here, then it will become like PQ like that. But for the position vector for Q, then it must be starting from also OQ is the position vector for Q. So that's the idea. Okay. So before we end the lesson, then we'll be doing like 4 example here together. Then after that, we'll be completing this lesson. Alright, so for this last 4 example, if let's say you are quite familiar with the idea that we discussed just now, right? You can try by your own first, then after that, you just go through the video to check your answer. Okay, so number 1, the position vector for the point ABC are given ABC respectively, where yeah, you have the column vector for each. So A, write ABC in terms of IJK. Yeah, so this is like a very simple question. So which means A will be equal to, so you have 2I plus 5J plus, sorry, minus 3K. Alright, so 3 dimensions, so you have IJK. So same thing goes for B. So 0, so which means that you can just do not need to write the I part. So 4j plus 6k. Then after that C, then it will be negative 4i plus 2j, then plus 24k. Alright, then B, giving your answer in terms of ijk, find the vectors that represent AB, AC, and AB and AC. Okay, so we know that these are position vector, right? So which means this is the position vector for A, B, and C. So all the vector here indicate what is the location for A, B, C with the reference from the origin. Okay, so in another words, which means the A here is basically the vector for OA. So for this one is for B, right? So that's why it's position vector for B. So it's from origin to B. So this is from origin to C. So this is OC. Okay, so after we have this information, then it will be very easy for us to find the answer for B already. So B1, we want to find AB. So AB will be equal to, so by using the idea for the addition that we learned, so OA plus OB. Okay, so AO will be the opposite of OA, right? So which means that you will need to do the negative. Okay, so negative OA and then plus OB. So now we can try to substitute the value that we have. So it depends on you whether you like to put it in a unit in a column vector first, then after that only your answer in IJK. So it will be depending on you. So if you try to write it in column vector, which means you don't need to repeat the IJK lah. So that's the only difference, I guess. So negative, then after that OA is 2, 5, negative 3. Then plus OB is 0, 4, and 6. Okay, so after we solve it, then negative 2, so negative 1, and also 9. Alright, so the answer one, the questions one, the answer in IJK. So let's try to change it. So 2i minus j plus 9k. Alright, so now we move on to part 2. So it's the same thing, but now we are doing for AC. So AC is equal to AO plus OC. So same thing, we do not have OA, so that's why it's negative OA. Sorry, we do not have AO, so that's why AO is negative OA. So plus OC, then I can continue. So negative OA, negative. Yeah, so let's try to do IJ maybe. So I2i plus 5j. I'm just showing you different way lah, but both can be accepted, whether you like it in the way of column vector or you like it in IJK. So plus, so OC is negative 4i plus 2j and plus 24k. Okay, so same thing, I and I, so negative 2, negative 4, so negative 6i. Then after that, negative 5 and also plus 2, so negative 3. Then after that, negative 3, so 3 plus 24, so plus 27k. Okay, so that's the part. Okay, so C, describe the relationship between points A, B, C. Justify your answer. So meaning that you will need to find out. So normally when we try to talk about relationship, right? Later we'll be looking at this part in a more detailed way when we try to move on to the to next week. So but the idea that when we try to talk about relationship is like few things that we know, like for example parallel, they intersect and so on. So we didn't learn the part about intersect first, so basically it's about parallel lah. So which means that we need to find out whether the points are parallel to each other. Okay, so from the answer that you have in AB, right, so you will realize that if AB is equal to negative 2i minus j plus 9k, and AC is negative 6, negative 3, and 27, do you realize that there is a scalar multiple here? So which means that for AB, right, you can see that AB, so AC is bigger. So AC is actually triple of AB, if you can realize. So like negative 2 multiply 3, I get negative 6. So negative 1 multiply 3, I get negative 3. 9 multiply 3, then I get 27. So which means AC is equal to 3AB. So because of I can write it in this way, so I know that ABC, they are parallel. So the line of AC and AB are parallel. And one more thing that you can realize here is if let's say AC and AB are parallel, right? What does that mean? Which means that AC is like this. So it's like triple. Then you have AB, right? So AB maybe is like this. So like three times. So one, two, three. So this is like from A to B. Then this is AC. So that's why they are parallel. And there's one more than parallel is that three of the point are actually on the same line because AC and AB they share the same point, right? So AC and AB are parallel and A is the common point. Okay, so because of they are sharing the common point, so we call this relationship as collinear. Okay, thus ABC are collinear. So what does that mean by collinear? Collinear in a simple word, right, is actually just that A, B, C are on the same line. So collinear meaning like all the points are situated on the same line. So in a more mathematical form, it's called as collinear. All right, so that's the idea. So remember, every time when you want to prove that they are collinear, right, which means that you need to prove that they are parallel, then you need to prove that they have one common point. So only that you can see that the points are collinear. Okay, so that's it for number one. So move on to number two. All right, so number eight, this is quite a simple question. So basically, it's for your understanding about position vector only. Okay, so given that AB is 2I plus 5J minus 3K, so the position vector for point A, so you need to know how to write this in a vector form. So position vector of point A, which means that from origin to A is actually 3I minus J plus 2K. Okay, so they want us to find the position vector for B, so which means we need to find OB. So by using the law of the addition, so we know that OB by using the unknown that we have, another unknown that we have here, which is A, so which means OB will be equal to OA plus AB. Okay, so as simple as that, so which means that you can substitute the value over here, then you will be able to get 5I, then plus 4J, and after that minus K. So that's it for the answer. Okay. All right. So number nine. All right, number nine. So this is a question that I wish to let you guys familiar with like the three-dimensional space. Okay. So the diagram here shows a cube. So the side length is like 4 centimeter. So the unit vector ijk are parallel to OC. So you can see like OC, then OA, and also OD. So ijk. So M lies on FB, so that FM is 1 cm, so which means this is 1, okay? And N is the midpoint, so which means that the distance here and here should be the same. All right, then P is the center. So P is the center of the square face here. So express each of the vector NP and MP in terms of IJK. Okay, so from the first approach, right, I will go from the approach that to actually just read it from the diagram that we have. Then after that, the second approach will be using the position vector to help us to find the answer. Okay, so let's start with the normal reading one first. So this is our NP, right? So you can imagine that it's actually is a straight line like this. So NP, sorry, let me just try to make it like nicer. Yeah, so this is the vector. Okay, so what you can realize here is, let's say when we try to draw it right, so how can we move from N to P? So that's the idea that we want to find. So you can see that from me to move from N to P, right, actually I need to move in the way of the J direction until half of the square. Then I will go up in the K direction. So this is how I get to the P point. So here to here. Okay, so that's the idea. So which means that for NP, is going to be equal to, so I only move half, right? So we know that the side length is all 4, so which means here is 4, here is 4, and here is 4 as well. So when we try to move from N to the center, which means the perpendicular line from P, right? From here to here is going to be like 2 cm for the direction for J. So that's why it's 2J. Then after that, from this point, I'm moving up until the P here. So which means it's in the K direction. So it's 4 unit vector, right? So it's like 4K because 4 cm. So plus 4K. Okay, so I hope that you are still following. Okay, so this is the idea for the first one. So let's move on to the next one, which is the MP. So this is our M, so this is P. So same idea. The idea is how do we move M to P. Okay, so you can see that instead of like just moving like two way, so I'll need to move 3 here. Okay, how is that exactly? So we can try to look at it like IJK. Okay, so the first step that I need to do, right, is from M, then I'll need to move to the place where is the K first. Okay, can you try to imagine? So meaning like half of it. So meaning I'm moving like in the I direction, but it's negative I direction. So how many cm? Because I need to reach the half here, right? So it's going to be 2 cm. So that's why this is for MP. So for the I direction, it's negative 2I. Then after I reach this point, then how about the J? So I'll need to go in front. Can you get the idea? Because M is on the plan or at the back there, right? So for me to reach P, which means that at this point, I will need to move in front here. So that here, then I need to move up to here. That's the idea. So what is this? This is in the direction of J. So it's the same thing from the back to the middle as well. So it's going to be negative also. So negative 2J. Okay, then after that we continue. After we reach this point, then which means I will still need to go up so that I can reach P, right? So this is the direction of positive K. So how many unit do I need to move? Is 1 cm only. So that's why plus K. Okay, so that's the idea of it. Okay, so now the other alternative for us to do that is by using a position vector. So I'm going to show you it's going to give us the exact same answer. So like for example, the first one is NP. So for NP, then we will be using NO plus OP. So which means that I will need to find ON, so negative ON plus OP. Okay, so for ON, it's actually quite obvious. So this is my origin, right? So for me to reach N is basically 2N lah. It's basically 2 unit I lah. So the whole thing is 4, right? So if half, so which means it's 2, 2. So that's why 1I, 2I. So negative ON, so negative 2I. Is that okay? Then after that, go to OP. So for me to reach the P here, so which means that what do you need to do? So it will be another I, right? So plus 2I. Okay, then after that, what happened? I'll need to move from here to here, right? So that I can reach P. So for me to find OP, which means that I'll need to move from ON, then O to the middle, then O to up. So O here to the N here to the middle, then it will be positive 2J. Then after that, I'll go up, so plus 4K. So from that, then I'll be able to get the answer, which is 2I. So negative 2I plus 2I, then I get 0. So I left with 2J plus 4K, which is the exactly same answer as what I got just now. So same thing when we try to look at MP. So we'll be using MO plus OP, right? So MO plus, so it will be negative OM, then plus OP. So same thing, we try to check in the diagram. So M is here. So we are talking about the O here. So how can we move from, what is the position vector from O to M? So it will be from O to C first, right? So it will be 4I. So negative, so OM 4I. Then after that, from 4 to I, then I'll need to reach M, so which means I'll need to go along the J until the end also. So plus 4J. Then how many units I go up? So until M here, so which means it's only 3 cm. So plus 3K. Alright, then plus, so how about OP? So OP will be the exactly same thing like what I have find just now. So 2I plus 2J plus 4K. So let's check the answer. So negative 4I plus 2I, then I have negative 2I. So negative 4J plus 2, then I have negative 2J. Then negative 3K plus 4K, so plus K. So you can see that the answer is exactly the same by observation just now. Okay, so it depends on which approach that you like. So, but both will give you the same answer. Okay, so yeah, I hope that you can try to understand like the 3D direction kind of thing. Okay, so let's try to look at the very last question. Okay, last question. So this is a 3D space of question also. So A is a point of coordinate 1, 0, 3, and B is the point with coordinate 3, negative 2, and 6. So find by using column vector, find the vector of AB. Okay, so since we know that A is a point with coordinate 1, 0, 3, which means that we can try to create a position vector for A. Okay, so which means that from origin to A, right, is actually equal to 103. So same thing for B. So from origin to B, the vector is 3, negative 2, and 6. All right, so A, we need to find AB. So AB will be equal to AO plus OB. So since we do not have AO, but we have OA, right? So AO is actually negative OA plus OB. So now we can substitute the number. So 103 and plus OB is 3, negative 2, and 6. So let's try to solve it. So we have 2, negative 2, and then 3. Okay, so this is our answer for AB. Yeah, I think it's quite easy. So after that, B, the position vector for point C, which is a midpoint for AB. So let's try to look at it in this way. So if let's say this is our origin, right? Yeah, I know that it's pretty hard for us to actually draw a 3D one, but you can just treat it like a normal 2D plane. So if let's say this is our origin, right? So if this is our A and this is our B, then maybe C is like the midpoint here. So which means that I will need to find what is the position vector from here to here now. So you can imagine that, so if let's say I want to find OC, right? So what do I need? I can use OA, then after that I plus AC. So how do I get AC? So AC, since C is the midpoint, right? So we know that AC is going to be half of AB. Okay, so from there, then I'll be able to use the answer that I have in A just now, then 1 over 2, 2, negative 2, 3. So which means I know that AC is equal to 1, negative 1, and 3 over 2. Okay, so after I have this, then I can continue. So which means for me to get the position vector of C is OC will be equal to OA and then plus AC. Okay, so OA, I already have the value, so 103. Then AC is what I got just now, 1, negative 1, 3 over 2. So by solving this, then I'll be able to get my answer for OC, which is 2, negative 1, then 9 over 2. Alright, so 2, negative 1, yeah, correct. Alright, so after that for C, so OADB is a parallelogram. Find the position vector for the point D. So which means that OADB. So OA, so we are talking about the B here, so which means like the B here. Okay, then after that, I have another line here, which is D. So this will actually form a parallelogram. Okay, so I hope that you can get the idea. OADB. So maybe D will be at the up there. Okay, let me try to redraw it. So like the parallelogram like this. So it will be like O, A, then D here, then B here. So which means C is somewhere like in the middle here lah. Okay, so this is like the C because it's the midpoint of AB, right? Yeah, so this is like a assumption, so that's why you can see that the diagram is not very accurate if let's say we try to put in a parallelogram. Okay, so find the position vector for D. So I want to get the D here. So same thing, if let's say I can connect a line over here, right? Okay, so OD, so how can I get that? Okay, so if let's say we want to find OD, right? So you can see that if you want to get OD, so which means that we will need to use OA plus AD. So it's the same thing like if let's say you want to use OD plus OB plus BD also can. It will just give you the same answer. So do we have OA? We have it, right? Then after that, how about AD? So because it's a parallelogram, so we know that if AD has a vector is going to be the exactly same vector like OB, right? Because parallelogram, the opposite side must be parallel and the magnitude must be equal to each other. So that's why the vector AD should be equal to the vector for OB. So that's why instead of using AD, then which means that we can try to use OB here. Okay, so we can just solve it. So 103, I'm sorry, I think it's a bit packed here. So the space, yeah, I'm just going to answer everything like in one screen. Okay, so equal to, so from that, then I'll be able to get 4, -2, and 9. So that will be my answer. All right, so yeah, if you have any questions about this lesson, please feel free to just ask me personally. And remember to complete your homework before we move on to like much more difficult content in next week. All right, so that's it for today's lesson. Thank you.